All right, everybody, we have our next lab here. This one is going to be for double replacement. So for this lab, you're going to need to collect a total of 10 different bottles. We have a set of 5 here and a set of 5 here. These ones are all going to start with sodium, Na, sodium, Na, 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 Na. All these ones are going to end in nitrate, so NO3, 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 and this blue one is NO3. When you get your substances, you're also going to need a new grid, and same thing, this one, all of the rows are going to start with sodium, and all of the columns are going to end in nitrate. So you can set up your chemicals so that they match their labels, and just like on the last lab, we're going to set this up so that we have a total of 25 different reactions. For example, this is my nickel nitrate. What we're gonna be doing is we're gonna be putting, oh God, this is hard, hang on. In each square of this column, we're going to be putting just a couple of dots of water. Just kidding, this is not water. This is aqueous nickel nitrate. And then we're screwing this back on. And then where each of these intersects with a new compound, that's what we'll be combining. So for this first one, we're gonna see nickel nitrate and sodium iodide. Now, we don't need very much, just a couple of drops. And as I put this with our green one, we can see the color of the solution changes, but nothing else happens. So that would be considered a no reaction. Nothing happened here. The yellow combined with the green to make a slightly less green color, that's not a real reaction. That's like mixing blue Kool-Aid and red Kool-Aid to make purple. What we want to see is something else. So here we have sodium carbonate and our nickel nitrate. This one's more like a little eyedropper, so you have to like pour it over like this. Now when these two combine, what we see going on here is what we're looking for. I'm gonna try to get nice and close. What we see here is a powder formed inside of the two liquids. Now, if I go ahead and get a scoopula from my drawer, and I look very, very carefully at this, we can see that the liquid has become clear, and that murky stuff is a green color. So in our observations, we would say the aqueous solution became clear and that a solid green precipitate or powder formed. So this would be a double replacement reaction. This is a precipitate forming reaction. This is two aqueous solutions creating a new solid. This looks very different than that, right? We can see this is chunky. If we're getting chunky, that's a reaction. If we don't get chunkies, that's not a reaction. We would do this for all of these reactions, a total of 25. It shouldn't take you too long, but you have to be really careful not to let your liquids mix with one another unless they're in their designated square. And then if it helps you to have them set up like this so you can see which bottle goes in which row, I would suggest doing that. When you are all done, you're gonna grab some paper towels and you're gonna wipe off wipe off your board. Try to wipe it away from the entrance here so that the paper doesn't get wet. And then you'll put everything back exactly how you got it, nice and organized for our next groups. You'll throw away your paper towel, and if your hands feel kind of gross, you can always wash them in the sink. None of this stuff is really bad for you. The only consideration I think you need to make is this one here. This is silver nitrate. This can stain your hands and your clothing, but everything else is pretty much good to go. Nothing should be too bad for you. And then obviously this bad boy just goes right back here. So when you come over here, the lab area should look something like this. Nice, clean, organized with your papers all in a stack, ready to go. And then this goes back in the drawer, and our paper towel goes back into the garbage. And then the last thing, make sure that you are cleaning your desk, your counter, whatever, with the spray bottle of ThermoClean. So if you work out here on the tables, we want to make sure we're spraying this off with the big old bottle of ThermoClean so that when people sit there, they don't have to worry about sitting on chemicals. And if you don't know what it looks like, this is our ThermoClean. I'm going to try to keep this by our lab supplies, so if you grab it, please put it back where you found it. One last thing I want to add is on your lab right up here at the bottom, these questions are almost the exact same as the ones on previous labs. However, this very last part here, you're going to pick 4 reactions from the lab and answer the questions below for each one. So you're going to pick 4 squares that did something. You're going to write down their reactants and their products down here. Now this last part is what's different. We want you guys to write the balanced chemical equation 2 different ways. So what we're going to look for here is a symbol equation. Let's say we had, I'm going to pick one that doesn't react so you guys won't use it, but sodium iodide. This was aqueous. Now I'm just copying this from what it said up here in the grid. This said sodium iodide, and if I look at the paper, it says it's NaI. So sodium iodide combined with nickel nitrate. Again, I'm just getting this from the paper. Oh, I don't want a big 3, so we're gonna hit Control comma to make the 3 small, and then we'll hit Control comma again to get back to big. And then Control comma one more time with a 2 for that little 2 right there. So we combine sodium iodide and nickel nitrate. Now when we did that, hypothetically, if it had happened, it would have made a double replacement reaction where the metals switch. So the Na would switch places with the Ni. So instead of writing Na first, I would write Ni. And that's going to combine with our iodine. So that's capital N, little I, capital I. And then we would have the sodium with the nitrate, so NaNO3. Now for this, we would need to look at these chemical formulas and figure out what the right formulas are. We do that by looking at the charges. So nickel, I can tell from over here, has a charge of 2, because there's a 2 right there. So nickel has a charge of 2. Iodine, according to our periodic table, has a charge of 1. So if I have a 2 over here, a 1 over here, and I swap them and make them subscripts, I would end up with a 1 next to the nickel and a 2 next to the iodine. Oh, heck, I did that wrong. 2. Over here, sodium has a charge of 1, and nitrate, this NO3, that whole thing has a charge of -1, and that's on the back of the periodic table under the word nitrate. So 1 and 1, that formula looks perfect as it is. The last thing we need to do is find our states of matter. Now to do that, we're going to need our periodic table. Let's see. Oh my gosh, there's no periodic tables anywhere around here. So if you're like me in need of a periodic table, there's a bunch of extra copies up here at the front of the room. So on the back of our periodic table, we're looking for sodium and nitrate, and we're looking for nickel and iodide. So I'm gonna find this one first, nickel and iodine. So I wanna figure out, where does nickel, let's see, nickel. Here it is. Here's nickel, this whole column. Where does nickel intersect with iodide? Here's iodide. Ooh, this whole column. Oh, sorry, that's a row. This whole row. Okay, so where these 2 lines intersect, that says S for soluble. Soluble, like our notes say, means it's aqueous, AQ. So on my lab over here, I would write AQ for aqueous. AQ. Boop. And then I do the same thing. I'm looking for sodium and nitrate. So sodium and nitrate. Sodium is Na, it's right here. Now, if you look at sodium right now with me, see how all of these are S's? That means that no matter what it's with, it's going to be S, soluble. So anything with sodium is going to be soluble. So now I can write here, oh, I'm not gonna write S for soluble. No, soluble isn't S, it means aqueous, AQ, AQ. Now with that information, I've just given you a really big hint at how to do this lab, and I've also given you a really big hint on how to answer this question right here. Why did some reactions not happen at all? This information I just gave you is a really, really good hint. So think about what I just wrote very carefully. The question says we need to write the equation from the experiment 2 different ways, and it has to be balanced. So if I'm looking here, I have 1 sodium, 1 sodium, 1 iodine, 2 iodine. That means I need a 2 here. 1 nickel, 2 nitrate. Oh, I only have 1 nitrate here, so I need a 2. And that's it. If I look at every single atom, they're all balanced. 2 sodium, 2 sodium, 2 iodine, 1 nickel, 2 nitrate, 2 nitrate. So this would be the balanced chemical equation. And then we would need to write it in words. And for the words, we don't need it to be balanced. We just need like sodium iodide plus yada, yada, yada makes nickel iodide, yada, yada, yada. So only the symbol equation needs to be balanced. But that's one thing I'm going to be looking for. If it's not balanced, you're not going to get credit, okay? You'll need to do this a total of 4 times. So if you divide up the work with your group mates, you could each do 2. And that's it. If you have questions, just let me know.